All right, here for another month. We got quite a bit to talk about. As you've seen, I didn't have quite as much post this month as I probably have in other months. I haven't been sticking to the rigid, twice a week schedule. I've really just tried to be a little more natural flow, if you will. Anyway, um, we'll see. I'm hoping you see better videos than what I had been creating. They're a little more polished. They're just a little more time and care. It's something I'm a lot more proud to put out there. Um, that's really the core of why I'm doing it that way, just so that I want to have more than just a generic, here's a service call, let you go with it. Anyway, um, yeah. So with that, I think I've got some good ones coming up, but we've definitely the 3630 video was a really fun one to do for that York centrifugal, and that was really just a really good experience altogether. I hadn't done that retrofit before. I've worked on the 3630 boards before, but really getting to see that transition, and I talked about it pretty in depth in the video, so I don't need to completely go through it all again here. But it's the biggest thing I really learned the most, I think, on that was making sure that you really pay attention to the fine details, and those jumpers are what really got me in trouble the most, for sure, without a doubt. So next time have a way better idea, and it's going to be next time. We've got several of those older series YKs that run the 2430 boards, and I think there's a 1730 as well, which is like the really old stuff. But yeah, it's just going to be a matter of time before we have to do an upgrade on those others. And the big benefit that is going to be great for the customer is they've got a board that is way more serviceable as they go forward and is easier to upgrade firmware on, and any other little hiccups or whatever it is they have that comes up. And they're not going to be changing that chiller, I mean, probably for another 10 years or so, which that chiller, I guess, sitting here thinking about it, is an early 2000. That chiller was, I guess it's about 20 years old now. But yeah, no, they won't be switching it out. Now, there is a chiller right beside that one, beside that YK, and it's probably at least an 80s. It's an old, I think it's a YT if I remember right. It's a low pressure. It's kind of a small machine. It's not as big as the one we were working on, but it completely crashed. I don't know, a couple of years ago at least. It may be more than that. Anyway, the motor failed on it, and then it has some other issues, throughout along the way. I don't know the full story on that other, but we were talking to them about trying to change that chiller out, a couple of years ago, but then COVID happened and the shutdowns and just everything went crazy, and they just completely lost their budget at that point. So that led to, there's no telling when that's gonna ever come back around. I see you, Archer. How you doing? I saw Jason Johnson as well. Go Bengals. Yeah. Okay. And we've got Diamond Boots. So you got any advice for someone interested in the chiller side of things? My biggest advice, especially, this is kind of true across the board, but you're really gonna find this when you start getting into that chiller side, where you start using water heat exchangers of any kind, and that is, you really need to understand more than just kind of have a concept of. No, you need to have a firm foundation in refrigerant saturations and how the saturation and heat transfer curves happen, because a lot of the times, and you start talking about really critiquing some very fine efficiencies, and you start talking about really tight numbers of approach, and we deal with superheats that are, I mean, you may be running half a degree of superheat from the suction saturation to the inlet of the impeller. So really tight readings, and it's you have to have a very firm foundation as to what all that means and what it all looks like. If you don't, it's not that you won't get by, and you'll probably be okay, but you'll never be that excelled tech, that guy that everybody thinks they need to call to bring in when nothing ever works right. If you want to be that guy, you're gonna have to do that to get there. So anyway, like I said, end of the day, that kind of applies across the board in the industry. Whether you want to work on your regular RTUs or not, you need to have that firm foundation regardless. But it's going to benefit you so much more to take that to the next level um, if you have that going into chillers. Now, I'll point it out now, not my typical front porch setup. I decided to try something a little different. As you can see, my trash bucket, I didn't dump it. I'm actually just now realizing that as I'm talking about it. Anyway, you can see, there's my trash bin for the truck. So yeah, we're just doing this. This is live. This is live. There ain't no hiding. Okay. Service York. Curious to know. I tell you, the worst chiller, this kind of just popped in my head after seeing what Jason was talking about there. I had it was a 70s, 80s model YT. Actually, no, it wasn't even that old. It may have been later 80s, early 90s. It was when the Millennium controllers were still being used, which I guess that was technically the 90s. Anyway, it was a YT, which means a low pressure centrifugal, York specifically, and uh, it had several people do some recent repairs on it. Now, I don't know the full story of that one either, but I was brought in basically to try to revive it. Several people had worked on it. It had several problems. Just some stuff was not done correctly. And actually, what ended up happening was I finally got down, and in this chiller on the bottom liquid line, they had a shell filter dryer, and I had done all the other repairs, had done everything. And the last thing I do is I pull those cores out to change them and get them back up. Well, after several days, like basically about a week's worth of repairs and different work and whatnot, I finally get down to pull those cores out. And quite literally, the whole cavity of that shell was filled with literal sludge. It was the worst thing I'd ever seen. I mean, it was horrible. So I pulled it all apart, and I get to looking at it, and the sludge itself is just full of metallic shavings, and they'd been having a lot of surging issues. They'd been having several problems. They had a bunch of bad sensors just scattered throughout the whole thing, so it couldn't read right, it couldn't run properly. Yeah, at that point, that chiller that was actually slated to be removed within the next 6 months to a year, and we just all agreed, just, you know what, that's it. um it's not worth bringing back. Like, one, the bearings, the journal bearings and things in that compressor were going to be completely gone. Like, that was it, they're done. Even if I did get it back online, there was absolutely no way it was going to run for very long, and there's no telling just how much that sludge had infiltrated the rest of the system. I mean, let me tell you, you're talking a couple of inches just holding in a shell that's probably 3 foot long. Maybe not that much, at least a 2 foot long shell. It was bad. Yeah, sometimes it's just better to just go. Okay. Da, 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 da. You guys, I'm curious to know, do you guys usually set the set point on entering water or leaving water temp? We typically use leaving water. Now, some plants will have it, like the building automation specifically, they'll monitor the entering water on the chillers in the loop. And if that gets above a certain value, they might cycle on other chillers to come in and support the main one running, whichever one is set to lead. But the chillers themselves will usually run a local set point of 45 or 46 degrees. Some run 44. The lowest plant I have, I've actually got two of them. They want to run 42, and that's because they've got other chill water issues throughout the building. It's not because the chiller really needs to run that. So anyway, yeah, that's our typical in my area of what we do. Sterling, greetings from South America. Welcome to the live. Can you talk about brine chillers? You know, Noah, I can't talk too much about brine. The only time we really see them is in like process cooling or maybe some of the heavier industrial side of things, which isn't a lot right now. It's something we're still kind of building to as a company. I've done that work. I don't want to speak to it as like a real source of authority because I'm really not. I know just enough about how to use the glycol and the brine mixtures to make it function. One of the big complaints I do have for those, and actually we were talking to customers over the last couple of months about, is they were asking, well, hey, we got possible freeze weather and all this other stuff coming up after what happened during last year's freeze. We don't want to rupture a bunch of pipes and stuff again. Should we put glycol in our loops? And ultimately, my answer is no. And it's largely because, one, our systems aren't designed to run with a glycol concentration, because what you lose there is you start to lose capacity and efficiency because that glycol doesn't transfer at the same rate as the regular water would. So you're reducing the capacity of that GPM and the heat capacity it can carry. So I've really steered customers away from that. But those are my biggest issues with it, is we're just not designed for it at 99% of our applications in my area. Okay. So yeah, the classes. So specifically the cooling tower class. If you haven't seen that, I really recommend you go back and watch that towards the beginning of January. One of my technicians put that on, and let me tell you, he did a phenomenal class. Really, really enjoyed. I sat in on that class. I mean, shoot, he brought things up in there that that helped me as a technician. So I really appreciate that guy. He did a great job in there. I'm trying to talk him in. He doesn't really care for the camera, so I'm trying to talk him into maybe doing some more. He's a wonderful presenter, even though who knew is actually, if you knew the guy in person, you wouldn't think so. Like I said, he absolutely hates the camera, but he did a fantastic job. I really recommend anybody go check out that cooling tower class and see what he did. It just is phenomenal. Let's see, we got a Sterling, kind of off topic. I recently almost lost an eye at work. I wear prescription just like you, and as you know, safety goggles can't fit over our glasses. So do you deal with that? Any tips? No, not really, honestly. It's I can't see without my glasses, genuinely. I mean, my hand a couple of feet in front of my face, it's fuzzy, just that close. So, and the further you get, just you can forget about it. Anyway, I don't have any suggestions. I have had several close calls myself. It's been something that I've just learned to be more cautious about, and I have had, doing grinding or using a cutting torch and stuff. I've had stuff spark and fly, and, I've had some really close calls. So I do recommend anybody, always have, even if they're a prescription, having a safety glasses prescription. I say that, and I should kind of practice my own words there. I don't, and I honestly, I don't plan to, but it is definitely wise. It's, yeah. We are the opposite. We spec and run glycol in our chillers here in Buffalo. Lots of free coolers. Yeah, well, and you got to think too, it makes sense for Buffalo. Freezes here just aren't a legitimate thing. Even this year, we've gotten below freezing, what, 4 times, 5 times, and you're talking at 12 hours. I think we had one day where we touched freezing below and kind of hung there maybe 24 hours. We've not had a legitimate heavy winter, which is not that unnormal for us. We just don't see that. Now you get out West Texas, that's a different story. But West Texas is nothing but just flat plains and just dirt and sand. There's not a whole lot there. But you get into the central Texas, North Texas, and East Texas side of things, we just don't see that kind of weather very often. So anyway, yeah, I really think for like Jason, you'd probably be a much better source than, and you could actually give, if you have some good tips, Jason, you could throw in the comments. I think that'd be great because that is something a lot of people really question. And I just have a small snippet of what I see on a daily basis. So, trying to keep up with the chat. Let's see, trains, any people were, we are the opposite. Having trouble with a YCIV 770 low discharge superheat, need help. A YCIV. So if you're having low discharge superheat, I would question, is your uh what's your superheat doing on those compressors? So if you're maintaining proper superheat going through that drain valve, then that's going to be the thing. And I've had it happen before where either the suction pressure transducer fails or the suction thermistor begins to get out of calibration. And one of those two things happens, it'll overfeed the evaporator barrel, and that will give you a low discharge superheat on a YCIV. So I highly recommend, if needed, verify that those two things are working properly. And that is, who was that said that? I don't even know how to pronounce that. Anyway, that's something that's the first things I would want to verify. And I have a video I did, I think in November or December. Now it wasn't an in-person live troubleshoot. I wasn't able to take a video at the time, but I took pictures of all the different screens and I kind of talked through the troubleshooting process. And I explain how a bad suction transducer caused a low discharge superheat. It may even be an almost exact situation to what you're dealing with, and that's kind of what I'm speaking towards. So I highly recommend go check that video out. I don't remember the title, but it was a York YCIV that I was working on at the time. I'm gonna try to move down on my list here. The LG 150 video, man, I tell you, LG, if you're listening, if you ever do listen, please, please, just please find a better communication system, network, something. I have had more issues with LG's COM bus and the way it's set up and the AC smarts. The system itself, when it works, the mechanical operations, honestly, you did okay, LG. Like you got about where you needed to be, but you really missed the mark on the COM bus side, and that's where Daikin's kind of kicking your butt right now, because while it's not perfect either, it is way less buggy and actually functions to a degree, and just, oh man, LG, please, just if you can hear my voice, please fix your COM bus issues and your tech support problems. Your tech support technicians, oh good grief. I'm not even going to get started on that. I'm still dealing with customers that your tech support guys just completely screw us over because they don't know enough about what they're recommending. Anyway, yeah. So LG 150 code, that was a fun adventure. That unit, ever since we reset it and we did all the work to it that day, that was end of, what was that? End of December, going into January, something like that. Yeah, that ended up working out. We've not had any other significant issues or anything at all going on with that system. That's also the same system. While I was there that day, I went ahead and did the test mode and the service mode videos. So those are just some how-tos, how to go through it on the interface itself, and then how you can plug the laptop module in, the LG MV, and make it work through that as well. So yeah, if you haven't seen those, or if you ever run up into those needing to do that on that equipment, there's some good resources for that. All right, so we got an update. Transducers and sensors were replaced. Okay. So I'm assuming after you did the transducer, the suction transducer, and the suction thermistor, you're still having that issue. The only other major alternative I could provide is hang on a sec, guys. That sun is here. We'll make that work. The sun's messing with my phone. I just got a notification. I'm starting to run hot. Anyway, we'll figure this out. Maybe this wasn't as good of an idea as I was hoping. Anyway, if it shuts down on me, that's why. My phone overheated. I'm sorry. Anyway, till then, we'll keep rolling. If you've done those sensors, I question, did you do everything? It's possible. So if it's not actually flooding back and you're not actually getting an overfeed on the drain valve or anything, then it is also possible that maybe your discharge side, the discharge thermistor or the discharge pressure transducer, those could be having. All right. I tried to do a fast scramble. Hopefully I haven't completely lost everybody. Yeah, it did. It overheated. I tried relocating. I'm actually going to do this a little bit different. Okay. Trying to get it out of the sun there. Sorry about that. Slight intermission. Am I back? Can everybody hear me? Can everybody hear me? I'm hoping I'm back. I don't think I lost everybody. Yeah, eventually I'll get this right. Like one of these days, I'll learn how to live stream. I promise. Don't worry. Anywho, okay, all right. I'm seeing some response now. Okay, sweet. Where did I leave off? I'm gonna try not to overheat again. I usually his phone is surging. That's nice. I usually do this without the case on, and that was one of the things I forgot. I got in a hurry. Well, I didn't think to take the case off, and then I had it sitting on the dash, and your windshield turns into a really nice magnifying glass. And when that happens, I got tired of it. Anyway, back to where I was. Actually, I don't even remember where I was now. Oh, we were talking about the YCIV tripping on the low discharge superheat. So anyway, I hope that y'all caught most of that. I'm still. It sounds like it's still a sensor issue, because if your suction side was actually reading properly on that YCIV and you have a low discharge superheat, then you should see, really low suction superheat coming through. You'd be flooding that compressor, or you've got bad sensors on your discharge side. So, you really need to look at those sensors and take a closer look and see something isn't right there. Let's get back to hang on a sec, guys. I'm sorry. I got miscombobulated here. Now I gotta get my notes back out. Okay, yeah, so the video that posted, what was that, yesterday? Yeah, yesterday, last night, actually. So the A200 code, I was just going to speak briefly about that. That was a pretty fun call. I don't get too many that just kind of, it was a one-off call, because, having the HOA not work due to the transformer, and then having the breaker, didn't actually trip. Those are just little fun nuances that you don't get to see all the time. And that was actually a pretty fun call. Now, for those who don't know, the A200 is a flow alarm. If you haven't established the flow switch, which I have an electronic flow sensor on this one, if that doesn't see flow within 3 minutes of going occupied, then it will trip the A200, and it'll never bring on mechanical cooling. If you see an A200 or 201 code, then that means that during mechanical operation, means where the compressors were running, we lost flow or just randomly, which that's going to be an immediate shutdown at that point. And then the A202 is when after the chiller goes to unoccupied, it expects the flow sensor to lose flow. That meaning that the pump turned off because, well, the chiller is unoccupied. And what that'll lead to is if it still sees flow, even though the chiller's in an unoccupied state, it'll think that the flow sensor has now failed and it's showing flow and it really doesn't. It doesn't have, or it's not supposed to have it, and it'll trip a A202. So you have to kind of keep that in mind. And those comfort links are a little different in that way. And this particular one was an absolute pain in the butt whenever we installed it, and then we were trying to tune it in with the automation system, and the windows on the comfort link were so narrow that the automation had a hard time just perfectly syncing with the comfort link controls on that carrier. And eventually we just said screw it. We ended up just having the chiller itself control all the pump function, and yeah, we just rolled with it from there. So that was kind of a pain, but yeah, you live and learn. Let's see. Sterling with the fans 0 to 10. I believe they are 0 to 10. It is those fans. This is what they call the green speed, I think. So those fans are modulating. They're on a Danfoss VFD on the back side of the chiller, opposite to the control interface. And that particular one had 4 fans, and it runs all 4 of those fans off of that same drive. Do 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 do. I just got a PLC tool signal generator. Yeah, signal generators are an absolute must in our trade today. I just did a training class January for our in-house guys, and I went into just modern control troubleshooting, and the fact that we've got inputs, we've got outputs, and this is, we no longer have series-based control systems and networks to where, we've got our high pressure, low pressure, and, discharge temperature sensors ran in series with our compressor contacts. No, those days are gone. Even on regular split systems, we have a high pressure switch output. We have a low pressure switch, or I'm sorry, input. So we've got these safety inputs, and if any of those inputs fail, that will kill the like the contactor output from the control board. So having those realities, whether you're troubleshooting transducers or whatever it is, a signal generator just becomes absolutely necessary, without a doubt. That is a big investment everybody needs to make. And I'm sorry, I'm trying not to shake it too much. I'm trying to keep the camera out of the sun. All right, let's see. I did have a question come in that I was going to answer real quick in one of the comments on how to remove moisture from like a centrifugal chiller. So my recommendation there is it depends on how bad we're talking. If we're talking like a low pressure machine that just has a small leak somewhere, you definitely have to get your purge system fully functional, and that's really, really critical. If you're questioning whether that purge unit is properly cooling or not, you need to completely go through it. You need to make sure the condenser coil is cleaned. You need to make sure that the the moisture chamber or the evaporator chamber on that purge unit is not holding a bunch of water or anything in it. So which would affect its ability to drain. And you also need to verify that it doesn't have any leaks, and you haven't lost any charge on that purge unit. So if that's the case, then one, depending on the size of the leak on that centrifugal, that purge unit will usually keep up to a point. But that's just something to be aware of. Now, if you've actually had a situation where you've gotten legitimate water and moisture inside of this thing, you can salvage it. It's going to take a lot of nitrogen purging. It's going to take a lot of vacuum, and it's gonna be a while. It's not easy, really trying to get a low pressure centrifugal cleaned up and moisture, especially again if your purge system is not functioning properly. Now, when it comes to changing your purge dryer, honestly, it's really simple and easy. you definitely want to have isolation valves. Now, I have come across some chillers that have aftermarket purge systems on them, and they didn't install isolation. Appreciate that, guys. But so you can do a very fast hot swap, as you would call it, just to get a fresh dryer in there. I really don't recommend it, but it is doable. Essentially, my biggest recommendations are, if you can isolate it, isolate either side of those purge dryers, and then uh, you will you'll want to take some nylog, and make sure that if you're doing like a train style, so those trains have the big like canister style purge dryers. They've got O-rings in there. You need to be very careful with those O-rings. If you're doing a different type of system, like I think York just had like a flare style dryers that would put on. You use some nylog on those things. It'll really help those seal better. It'll go back together a lot easier. Um, so yeah, that would be my recommendations there. Let's see. Jason Johnson, I want to learn more about centrifugals. I don't have much hands-on with them. I understand how they operate and what the components are. I'd really like to get around them more often. I mean, yeah, they're a really fun side of the industry, and you want to really test and push yourself on a technical level and in just so many ways. Centrifugals will definitely do that. I mean, they will challenge a lot of your understanding, because like I said earlier in the live, you really got to have a strong foundation the fundamentals of this trade to be just an all out, just say, we'll call it super tech, whatever you want to call them, right? Um, let's see. Checking non-condensables. If your evap is cold and the condenser is at ambient, there's no pump on the system. Reversing valve. Yeah, non-condensables can be a pain. And something I've found recently is, uh, these blended refrigerants like 410A, for example. I had that RTU video I did, it was, I think, a couple of months ago, where the 410A had fractionated, and it wasn't non-condensables. It was the fractionization that caused the issues we were having with high head pressure and everything. I mean, it was crazy. But depending on the severity of how much atmosphere or moisture or anything gets in there will kind of depend on how hard it's going to be to identify it when you're doing a saturation test. So, are we having delivery issues from where did it go? Train in April. Yeah, keep in mind, it doesn't matter what brand you're ordering, whether it be Train, Daikin, York, Carrier, all of them. It's taking us, so we've done two this year. We've got a couple of more to do, chiller change outs, and we've got more we're looking at doing at the end of this year. So yeah, each one of those, they're telling us, the ones we've already been waiting on have taken a minimum of 7 months, up to 9 to 10 months to receive those chillers upon the ordering. And then the ones that we're currently getting ready to order, they're telling us, basically 8 or 9 months minimum before we're going to see those chillers leave their manufacturing plant and show up. So yeah, chiller equipment waiting on it right now, absolutely ridiculous. It doesn't matter if you're talking air cooled or centrifugal. It's tough. It is really, really tough. Okay, I'm gonna move on. I got another couple of bullet points. Oh, I was going to touch on, I had one question come in via email. Somebody was looking at possibly moving from state to state. Basically, their main question was they weren't sure how the licensing and things were going to work out. Now, in Texas specifically, we are required to have our EPA, 608. And I think everybody's required of that. And that is state transferable. That's not something that's issued directly in your state. That's something that you're going to be able to carry with you no matter where you go. Now, specifically in the state of Texas, you cannot practice on your own without having a state license here in Texas. And I think they will allow some licenses from other states to transfer into the state. But I don't know what the paperwork process on that looks like.
I've heard, I don't know this for fact, but I've heard that other states do not require an actual state license to practice air conditioning. You can just go out there and work on your own, and you don't have to have any prior qualifications. Like I said, if you do want to come to Texas and do that, they're not gonna. That's a really big fine. You have to work under somebody that has been approved by the state. Now, Sterling, I saw your question. Without a doubt, the Appion core removal tools, those are absolutely just must-haves in the tool bag. I've used several other core removals, and especially when it comes to doing vacuums and stuff, those Appions, the set I've had for a few years now, and I've other than changing the O-rings a couple of times in them, never had a problems with them. And I've pulled all kinds of equipment down with those things. And I have most of my team run with those Appion core remover tools, and they're pricey. I think they're like $50 each. Let me tell you, they are well worth the investment, and they really hold up, and they do well under a vacuum, where a lot of those others don't. They may be most of the others may do perfectly fine under positive pressure, but they will not take a vacuum worth a darn. So yeah, if I can recommend one, without a doubt. Input output signals on BAS. Sure, I can hit that real quick. Like I said, I've actually got two videos coming out. The trainings. The one I did was specifically mechanical equipment focused on input output troubleshooting on like chillers or RTUs. But we also, in our automation class for this month, we actually had one of our senior systems specialists. He went through like an in-depth look at the automation perspective on how they do inputs and outputs. And you kind of see the side-by-side comparison of that. So be looking for that to come out probably this next week. I'm going to do both of those videos probably tonight over the next couple of days and try to get those out this week. Now, keep in mind that will mean that my next service call video will be delayed, till maybe next weekend or something. So just bear that in mind. Be patient with me. I know not everybody enjoys my other content that I do. For those that are here strictly for the service call stuff, I do that just as much as I try to do the training stuff. But this channel is focused on not only showing you through experience how to practice different things, but also I want to, it's here for training. This whole purpose, all of it, is to help you become a better technician. So you're going to see training videos out there, and you just got to be patient with me. I've seen a couple of comments where guys are getting annoyed with all that kind of content coming out. Anyway, the difference between input and output is quite literally, so an output device would be something like a relay or a triac, which I have a video on triacs, closing to control like a valve, if you will. So you want to move this actuator, or you want to send a signal to close a contactor for a compressor. Well, that's going to be considered an output. It is a signal going out from the control board to activate or control some sort of device. A input would be something like a thermistor or a transducer. It's a device that is sending a signal back into the control board, so that it tells the board some form of a reading, so that it can act accordingly depending on whatever that scenario is. So that's your really basic difference between an input and an output. So when you see a component that's got a thermistor, you've got transducers, or anything of that nature, you've got input devices, and then all your contactors and your relays and those types of devices, actuators, those are all going to be output type devices. Let's see. Okay, I'm going to try to move on and wrap this up. We're starting to push up on an hour. So, the Aeon with the automation issue, where it was locking out. That's just a simple, the automation was actually storing a lockout internally on it for the supply air. So even though the RTU would not only, if it ever did trip, it would reset itself. The way that system was set up, to where if it saw the RTU trip, then the automation would also trip. And actually, on the second visit where I did that shorts video on, The RTU never actually tripped that low temp alarm. The automation had its own internal set point to where when it saw it cross that barrier, here, I'm gonna try to move this. The sun's. I feel like I'm shaking too much. When the sun, what am I saying? The automation used its own internal safety point, and it tripped and triggered the and its own safety, which locked out that RTU. And basically, it's just dropping out the start stop. So that's what's happening there. And once we get in, all we got to do is just pull that sequence out of the logic loop, and that'll stop the automation from triggering itself, and it'll let the RTU control itself like it needs to. So that was one of the things that did come up, was seeking a update on what that was going to turn out to. And so far, I mean, that'll be the resolution. We're having to work out the licensing issues for the automation side, and they've got stuff with that because we're not the ones that originally put that in or set that up. So we've got to get those kind of parameters from the customer itself. Anyway, the CGAM that I was doing the start stop on is another shorts video I did actually this week. Just to follow up on that one. That one's kind of an interesting one because they did a old school style, an old school style start stop. So what they're actually doing with that is there's a flow switch at the pump, at the chill water pump, and the pump is dedicated to that specific chiller. And so when the automation sends a signal, it actually sends a signal to close the relay for the pump to turn on and start. And after the pump starts, it closes that flow switch. It's just a paddle switch on the output of that pump, and that is actually our start stop relay. So when that closes, it closes the contacts in that flow switch, which then is wired back to the start stop contacts at the CGAM control board, and that's then the chiller knows that the automation wants it to turn on. So, and that's actually a really common way it used to be done a lot before automation systems became as robust as they are today. So a lot of plants have upgraded and transitioned away from that to where the pump and the chiller may receive individual start stops. Or obviously if you got a plant that is running, a common header to where you don't have dedicated pumps for the chillers, then obviously it would be a little bit different setup, but you get the point. That's how that particular one's running. We actually found after we got it all together that that flow switch actually ended up failing. And once I got it wired in, whether the pump was on or off, I could not get that flow switch armature to open. So we're going to be changing that out this coming week and putting a new flow switch in and finish getting that chiller wired in. So the automation has full control there. I don't know why this closed on me. Let's see. Yeah, and I will finish out with that electrical trainer. That's actually, we've got that one, and I've got another train one, a train panel that we're going to end up doing. And I'm still working on it. I haven't completely finished it, but that's a fun little project. So I'm really hoping our technicians are able to really pull a lot out of it and really see an in-depth troubleshoot. And I'll go in and simulate a bunch of issues and problems into it. So I pulled a Aqua Snap control panel out of I don't even remember what series it was, just an air-cooled carrier with scrolls in it. And so I pulled that out. I've got it mounted on a stand, and I've got all the electrical components I need, and I've got some resistors to simulate thermistors, and we can do some actual live troubleshoots on that thing. It's kind of same thing. I'll do the same thing with the train. Anyway, that train came out of a CGAM, yeah, something like that. Any final questions? Now's a good time to put them out there. I'll try to cover them. In the meantime, really appreciate y'all. This has been a lot of fun. Like I said, you might see you have seen fewer videos than I was doing for a long time, but I want to want to put out better stuff. I don't want to put out just a generic video just to say I got a video out. I want it to be engaging. I want it to be intriguing, and I want you to really enjoy that so that you can pull from that experience. Because at the end of the day, it's the whole point behind me even posting the video, is I want you to be able to go through and you see exactly what I saw and gain some knowledge, some experience, just gain something from that, so it'll help you on the next time. Because that is the heart and goal of this channel, is helping you improve so that you can improve to the point to provide a better life for yourself and a better life for your family. It's the whole point of everything that I'm doing here. So, hope that comes through. Hope y'all enjoy it. If there's anything I ever want to see or you'd like to learn more about, always feel free to send me an email requesting it. I try to do as much as I can. Uh, Things are always very challenging with my schedule. I got a lot of stuff going on all the time, so that's kind of part of what drives the lesser videos recently, is just trying to balance my schedule and trying to keep up with the posting schedule and video edits, and then still have, practice what I preach, right? I preach MTT, make time for your family. You have to make the time to do that. You're never going to have that time. You're always going to have to make that time. That's just life. That's the way it is. So, yeah, sometimes that means I may not get a video out that week, or I may only do one small video instead of a series of videos. And well, the reality is that's usually a week that work is very demanding, and I'm taking that time for my own family the same way I want you to take it for yours. With that, I want to close that out. I appreciate all of you. MTT, take care of your families, take care of your spouse. Your kids really need you. We'll see you later, guys.